Would be again, we have our important guest, Natalia, in the studio, where we can kick off the security observability session.
Hello, everyone, and welcome. My name is Natalia. I'm a security engineer here at Ivanko, and I have been working a couple of years now on security observability and runtime enforcement with eBPF, both in production environments with customers and clients, and on open source environments with the community. So in this talk, I would like to present how can we secure cloud-native workloads with the help of eBPF and the new open source project that we call Tetragon. So a little bit about the agenda. In the first section, I would like to talk about what is the activity that we care about when securing a cloud native workload, and what is the activity or the events that can be useful for a security team during an incident investigation or threat detection. Then we will jump directly into how can we spot this activity and then potentially block it with runtime enforcement. Then I will show you an open source tool that we are creating here at Isovalent. It's called Tetragon, and then we will see a quick demo on workload runtime visibility. So let's jump in directly into security observability and then into the events that we care about when securing a Kubernetes or a cloud native workload. So this is a list of events that can be useful when we are spotting or detecting or reporting any kind of malicious activity. And then these events are basically answering questions like what were the network connections that were made during a workload lifecycle, what were the processes that were executed, what were the files that were accessed, what were the capabilities and the namespaces that the process started with, or maybe gained meanwhile, and then what were the sensitive system calls that were made by a Kubernetes workload. So there are already existing solutions to be able to spot this kind of malicious activity. These solutions were created in the past, and then we will take a look at each of them and then compare it with the solution which is eBPF-based and then that we are creating here. And then we are going to deep dive into Tetragon, which is an open source tool created by the creators of Cilium. So this list includes LD Preload, Pretrace, Ptrace, SecComp, LSM, LSM eVPF, and then finally eBPF. So the first one is LD Preload. This is the oldest approach. With this, we are able to load a library into an application without any awareness or changing that application code. So we are essentially injecting that library into the application and then watching all the system calls that the application is performing with that library instead of using the kernel. So this is called LD Preload Proxy or System Call Proxy. This is great, but this can be actually bypassed. So if the application is statically linked, then LD Preload will have no effect. So we will lose all the visibility into system calls, and then any kind of enforcement will be ineffective. So this is already abandoned from that perspective. The next is we can do system call checks within the kernel. So we can do system call checks when we enter to or exit from a system call at the kernel level. There are well-defined hook points in the kernel for tracing entry to and then basically exit from a system call. You can hook into these hook points with ptrace, SecComp, and also SecComp profiles get evaluated here. And then you can also hook into these hook points with trace points or query probes to run eBPF programs. So this is already so much better than LD Preload because the application cannot actually bypass it easily with the injection of the library. But this is vulnerable to so-called TOC, TTUU attacks. This is time of check, time of use. So the hook point when the solution sees the system call is before the last point when the application can actually change it. So you can see it in the picture. The hook point is actually at the system call entry level, and then the system call handling copies the parameters from user space to the kernel, and then it's still possible for an application to change it to something else after the checks. There are a couple of references here. The most well-known is the Phantom attacks, which were presented at TFCon 2021. So to be able to avoid top 2 attacks, we need to make the checks at the right place in the kernel after the kernel copies those parameters. There are already existing solutions that are doing this, and there is a well-defined interface. It's called LSM API. LSM stands for Linux Security Modules. So it's a relatively old API and then allows to do security checks and enforcement at the right level. It is relatively stable, a safe place to make checks, but it requires additional kernel modules to load, and then it's static. So LSM is used by Apple, More, and Linux to check system calls against existing profiles, and then, for example, behavior, so which file can be accessed by which programs. And then a better known or better suited is BPF LSM. It uses EVPF to make LSM dynamic instead of the existing static solution. So it's a step forward and almost what we are creating here at Isovalent. So these API calls are already in the right place, and it's designed to be like in a high performance. You get access to the kernel data structures, which are already pre-populated with the right data, and then you can do the security checks at the right place. But it requires relatively new kernel modules. BPF LSM was introduced in 5.7, and then most of us using kernels in production environments older than that. And then it is also limited to hook points only that LSM provides. And then if you would like to introduce new hook points, then you actually need to change the kernel code. So that's why we created Tetragon. We want the same property in terms of safety, hook points, and security than BPF LSM, but we want to avoid additional kernel requirements. So we will be able to run like on older kernels, and then we would like to be able to add additional hook points rather than the one that you can find in LSM. And then we would like to have a shared state between BPF programs with BPF maps. This is basically the yellow database that you can see it in the pictures. And then this allows multiple eBPF programs to work together. And then it also allows in-kernel filtering, which is basically gives you a really high performance. So this is where we arrive to Tetragon. Tetragon is an eBPF-based solution providing combined runtime and network security observability and runtime enforcement to Kubernetes and cloud-native workloads. It runs on the top of the Linux operating system. It can be Kubernetes, cloud-native environments, or bare metal VMs. If it's a Kubernetes environment, it runs as a daemon set, and then if it's a bare metal VM, then it runs as a container. It uses eBPF programs to collect the events exactly defined directly from the kernel, and then you can basically filter with very high performance what were the processes, networking events, or files that you would like to collect, and then what are the circumstances that you would like to be able to detect, for example, namespaces and then capability changes. And then all of these events can be traced by security policies. The security policies are dynamic. You can load them anytime without, for example, restarting the application or the pod. And then the pod doesn't even have to reach the ready state for the policy to take effect. So with these policies, we are able to observe arbitrary events inside the kernel. Right now, 2 main types are supported, kprobes and then trace points. And then with kprobes, we are able to observe arbitrary functions and then system calls inside the kernel. So in the following demo, I would like to show you how privileged pod starts and then opens its password, and then how it can be traced and then blocked by an eBPF-based solution, which provides security observability and runtime enforcement. So here I have two terminals, and I already have a GK cluster set up and running, and I already deployed Tetragon. We can check the nodes, and then it should be kernel 5.10. And then what I'm going to do, I will apply a test pod on this cluster, and then I will try to edit the etc password file. And then I already have a security policy applied, which should block the syswrite system call trying to edit this etc password file coming from that test pod. So I will start observing the events from this pod via CLI. And then I'm going to apply this test pod. And then it will take a couple of seconds for the image to download, and then we should be see a bash terminal already. I give get as execting already, and then let's try to edit the etc password file. We already see the bin bash and then also the bin groups process that were executed. So let's try to edit etc password. And then we already see some open and close events on the bottom coming from the etc password file. And then let's just try to add Natalia. And then try to close it. And then we already see the write event on the bottom. We saw the binary name, we saw the file name, and then actually that 930 bytes were tried to write to etc password. And then we already see the exit event with a signal that is secure. So with this, I would like to say thank you also on the behalf of the Tetragon team. And I would like to open this discussion for a Q&A.
Cool. Thanks, Natalia, for the wonderful session there. So I'm just checking if you have any questions from the chat, or I don't see anything. Anybody want to ask any questions, or
Everyone is speechless.
Yes, I think so. But I just would like to ask, what is that you would like to have like a takeaway from your speech that we should concentrate on, or maybe what is the giveaway from you to the audience?
So I just wanted to give like a quick overview, like what are the events that can be helpful for a security team during like a container lifecycle or a cloud native work lifecycle, and then basically how can you monitor it with existing technologies, and then why eBPF would be the most optimal to do it.
Cool.
Yeah.
Arel, good comment there. I think we also have a plan to arrange a follow up with Natalia. I will bring her back again for sure. If you need a more detailed version, I know it's a little bit short and sweet with a lot of information to digest. Probably I might arrange another session with where we can go a deep dive on the talk.
Sure, we can do like a more detailed one for like 30 minutes or like over an hour. Should be fine.
Yes, she is, I think, yeah. Yeah. I think, yeah, Mohammed and the rest, yeah, Aaron. Probably I'll set up another session, deep dive in this chat, obviously, and we can drill down. There's a survey at the end of this talk session, so please feel free to mention what would you like to hear from Natalia in the next session. So maybe she can, help us prepare and share more insights there.
Also, if you would like to need more like introduction or like more details around it, then I can probably deep dive.
Yeah, sure.
Okay, thanks a lot for
Cool.
inviting Mado again.
No problem. Thanks, Natalia.
Thank
That was
you,
a great
guys.
session. Cool. Yeah, it's a little bit complicated for me as well. Even I know containers in and outs, I still felt very refreshing with that session there. So thanks, Natalia. That was really great, really great.